Good morning. We are going to talk about how to simplify radicals. Again, this is just a review of something that we've already done, so I'm going to take it kind of quickly. Feel free to pause the video to try it on your own and see if you remember. However you want to use this video, that is totally up to you. So when we did simplifying radicals, we used the prime factorization factor tree method to do it. I'm going to actually use my calculator just for anybody who needs to see it that way. If I can find my calculator. Desmos is my favorite. Okay, there we go. All right, so I'm pulling up Desmos on my phone so I can show you how to do it if you can't just think about it. So what you want to do is check this number and find its prime factors. It's really easy to look at 2 as the first one. So you would have 2 and 81. All right, 2 is prime, meaning you can only divide it by 1 and itself, so I'm going to circle it. Now, I know that 81 is a perfect square, but if you haven't memorized your perfect squares, here's how you would continue. You would say, okay, well, what can I divide 81 by? Can I do 81 divided by 2? No, it is a decimal. 81 divided by 3? Yes. 81 is 3, which is prime, times 27. And we're going to keep breaking it down. What can we divide 27 by evenly? 27 divided by 2? No. By 3? Yes. 3, which is prime, and 9. Okay, keep going. Most of you know, I hope, that that 9 is 3 times 3. Both of those numbers are prime, and so now the ends of our branches are all circled as prime numbers. We're going to rewrite this as 2 times 3 times 3 times 3 times 3. You can see I just took the ends of the branches and wrote them out under the radical. The index of a radical, when it's not written there, is 2, which means that we need to pull out any groups of 2 that we have under there. Because remember, to be under the radical, perfect square is something times itself. So 2 has no friends. We have a pair of 3s, so those are going to go outside. We have another pair of 3s, so those are going to go outside. And left inside, we just have our lonely 2. Okay. The reason that works is because 3 times 3 is 9, and the square root of 9 is 3. That's why we only bring 1 out. Okay? And then you just multiply the stuff on the outside. 3 times 3 is 9, and the square root of 2. That is a simplified radical. Of course, in class, we gave a much more detailed explanation of how and why, but for right now, it's just a process. Can you do it? All right, so let's do 3 examples together. Again, if you know what you're doing, go ahead and then just check your answer with mine. This one's a little bit different because we have a radical out front, so we just need to know not to forget it when we get down to there. All right, so prime factors. I know 245 is not divisible by 2. Depending on how good you are with these things, you can just type them in. I know it's divisible by 5, so I'm going to do 5 and 49. 5 is prime, and I'm going to keep going. 49 is 7 times 7, and those are both prime. All right, so now inside, we're going to do 5 times 7 times 7. All right, because our index is a 2, you can't see it, but it's there. We are going to take out groups of 2 of the same. That's how you make a perfect square. So this is going to go out here. 2, now times 7, and our leftover 5 is inside. 2 times 7 is 14. Root 5 is the answer. All right. The next one has a little bit more. This one has some variables too. Again, we're going to pull those out in groups of 2. I'll show you the long way to do it, and then I'll kind of explain how I do it. First, we want to break down our number. 80 would be 8 times 10. And of course, you can break these down whatever way is easiest for you. You may see it slightly different from me. That's fine. So we're going to rewrite it as 2, 2, 2, 1, 2, 3, a 5, and a 2. And we have 9 A's. A to the 9th means you have 1, 2, 3, 4, 5, 6, 7, 8, 9 A's. We have 2 B's, B squared, and 25 C's. That is a lot. I am actually going to write them out for visual purposes, but normally I would not. Okay, 25 C's. Now, we're at the stage where we want to pull out pairs, 2 of the same thing, to put in our final answer. Anything that we have 2 of the same is going to go on the outside. So here we have a pair of 2's. Here is another pair of 2's. All right, I'm going to switch colors just for excitement. All right, we have a pair of A's. 1, 2, 3, 4 pairs of A's. Okay, we have a pair of B's. And, goodness, let's see how many C's do we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 C's. Oh, goodness. Okay, 12 C's. Whew. Okay. So now inside, what do we have left? We have a 5. Look through. Oh, there's an A. No more B's. And we have 1 lonely C there at the end. All right. And we're going to rewrite this nicely now. 2 times 2 is 4. A, B, C. We have 1, 2, 3, 4 A's, 1 B, and 12 C's. This is the simplified answer. It looks a little crazy, but that's how you do it. That's the process. Again, the reason why we talked about in class. Number 3, one slight difference here, and that is that we have a 3 right here. When you have a 3 there, or any number, that tells you how many are in a group when you pull it out. So here we had nothing. That means there's a 2. That means there's an implied 2. So we pulled out groups of 2 of the same. This time we're going to do groups of 3. 25 is the same as 250. 25 times 10. And I'm just doing prime factorization here. Oh, that was easier than I thought. All right, don't forget that this 2 comes along for the ride. All right, so we have that -2 from the beginning and all of our stuff. 1, 2, 3, that's all those. And we have 1, 2, 3, 4, 5, 6 M's and 10 N's. All right, this time is different. We're going to be pulling out groups of 3 of the same. So here we have 3 5's. So we have this -2 that came along from the beginning. Okay, and now we have a 5 because those went outside. We need groups of 3, so we have 3 M's and 3 more M's. So we have 2 groups of M. And then we have to get groups of 3. We have 3 groups of N's. And what we have left inside is a 2 and an N. All right. And gosh, this is a mess. All right, and lastly, we're going to simplify. So -2 times 5 is -10. We have 2 M's, so M squared. 3 N's, N cubed, root 2N. And this is almost a perfect answer, but I forgot to put the little 3 index right there. All right, I've been trying to use some of the more challenging problems as examples on these videos. Hopefully that's not doing more harm than good. All right, have a wonderful day. Bye.